In Chapter 4, Section 8, we're going to look at Newton's method. And this is a method to quickly find roots of a polynomial function by looking at the ratio of the function to its derivative and then subtracting it from a guess for the solution to the problem. So what we're going to have is, this is the formula. We have x n plus 1 equals xn minus the function evaluated at xn divided by the derivative of the function evaluated at xn. And this is going to seem a little bit strange at first, so I think the best way to do it is we'll do some problems and you'll see how it's going to work. So let's look at problem 1. It says, starting with x1 equal 3, find the third approximation x3 to the root of the equation x to the third minus 2x minus 18. So in all of these problems, we're given a function, in this case x3 minus 2x minus 18. And according to Newton's method, we need the derivative of that function, which we know how to do now. So we take the derivative of this, bring the 3 down, make it a 2, and then the x goes away and the 18 also goes away. So that's the derivative and the answer to the first part of this equation. Then according to this formula it says, take the original function f of x and divide by its derivative. And what they've done here is they've said x is generally x sub n. Now, it's just, n is just a placeholder, so we're going to have x1, then x2, then x3, then x4, and n will keep going up. So the first n we have is n equal 1. So we replace this n with 1 and we get x1 in x1 and x1 in the denominator. But we know x1 is 3. So first they show it with just x1s. This 3 came from the coefficient of this x squared, and then it becomes x1 squared, and then this minus 2 comes from this part of the equation, of the derivative. Now we're actually going to plug in 3. So anywhere we see an x1, we plug in 3. So we get on the top 3 cubed, minus 2 times 3, minus 18 on the bottom. We get 3 times 3 squared, minus 2. On top, we're going to get 27 minus 6 minus 18. And on the bottom, we're going to get 3 times 9 minus 2, which is 25. And if you're very careful, this takes some clever calculator work, and you take these f of x and f prime of x, you should get 2.88. Now here's the beauty of Newton's method. That now becomes our next guess. So I should have maybe set that up a little better. So we have this function, x cubed minus 2x minus 18. And it's going, so x cubed generally comes up, and usually it goes through the origin, but it's probably not going to go through this origin. And then it might come down again and do something like that. We could go to decimals.com or something to get the actual picture. But what we're trying to do is find this 0. So we're trying to find that point right there where it crosses the x-axis. To find that, we don't know where it is, so we take a guess. And that guess is called x1. And in this problem, they guessed 3. And if you look at 3, 27 minus 6, which is 21, minus 18 is 3. Well, that's pretty close. So we wanted 0 and we ended up with 3. So it's probably close to 3. And then so we start with 3 and we go through Newton's method, and then we say 2.88 is closer. So now that becomes our guess. So now we use the exact same formula, but everywhere we see an x, we're going to replace it with 2.88, and that's called x2. So x2 is now 2.88. And then we go through and put in 2.88, and you can see that here we put 2.88, 2.88, and if you plug in 2.88 in the derivative function, you get 22.833, 22.8832. And then you subtract that from 2.88, and when you do this, you get x3 is equal to 2.88. 0.8744. And we're getting closer and closer to the actual number. And for this problem, they just have you do this twice, so we're going to stop there. But you might end up doing this 3, 4, 5 times until you get a difference between these two numbers that is small enough. So they'll say correct to 6 decimal places, or we'll do a problem where it's 8 decimal places. You have to keep doing this process until you get the difference in the numbers. The numbers won't even change. Okay, so that's problem 1, and I would suspect this is still seem a little strange. So let's try problem 2 and see if it will start to make better sense. So it says use Newton's method to find the 6th root of 5 correct to 8 decimal places. And then they tell you, well, that's really like taking the function x6 minus 5 equals 0. So if we have f of x equal x to the 6 minus 5, well, if we set that equal to 0 and add 5 to both sides, we'll get x6 equal 5, or x equals the 6th root of 5. So this function is the same as finding the 6th root of 5. Now we're going to take a derivative of this. So we're going to get 6x to the 5th. And then Newton's method says my second guess should equal my first guess minus the function x6 minus 5 divided by the derivative 6x to the 5th. And actually I should put little n's here to indicate that those change depending on how many iterations I've gone through. So this is how Newton's formula will be edited for our specific problem. And the first thing they want to know is just the derivative function, which we have. Then they want us to replace these x's with xn, which means it could change. And then they do a lot of the work for us. So they say when you plug in the first guess, x1 is 1, you get your second guess is 1.6666. Then you plug that in and you get your next guess is 1.453. Then that becomes your next guess and you get 1.339. Then that becomes your next guess, which gives you 1.309. That's your next guess, which becomes 1.307. And then you can see that these numbers don't even change between x7 and x8 to 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So we are very, very confident that this last number is the solution to this problem. Okay, now these problems are super tedious if you use a calculator, especially if you use just like a scientific calculator. If you've got a graphing calculator, you can program these functions in and it becomes a lot faster. But I'll actually teach you to use Microsoft Excel to do these problems, and we're only going to use that to do the homework. I would not ask you a problem on a test that would require you to use Microsoft Excel or a fancy calculator. So these first couple problems might be good ones to look at because you don't need to get these numbers. You just need to understand the setup and then look at how these numbers, we call it converge, on a solution. Okay, so let's keep going and see how this works even more. So here we have when does cosine x equal x? So when do these two curves meet? So we want to find this answer. Notice that a good guess for x1 would be 1. So that's pretty close to the actual answer. But Newton's method always has to solve the function equals 0. So I can't solve cosine x equal x. What we have to solve is cosine x minus x. So we're going to bring this x over. So we say let the function be cosine x minus x equal to 0. And then the derivative function is pretty straightforward. The derivative of cosine x is minus sine x. And the derivative of minus x is minus 1. So that's the derivative function. And so Newton's method says our second guess equals our first guess minus the original function, which is cosine x minus x, over minus sine x minus 1. and we should put little ends on these. And the ends, like I say, would mean they start at 1, and this says, okay, then x1 gives me x2, xn plus 1. So if n is 1, this left side becomes x2. When n is 2, on the right side you have x2, but on the left side you get x3. So each one feeds into the next x, the next guess. So we started at 1, and then it says, well, a better number is 0.75, then 0.739, then 0.73908, then 0.73908,513. And these numbers are the same. Once they're the same, you can stop. So you can stop this algorithm, and you're going to say, okay, this one is the best answer. And we just need to type that in. Okay, so the first three, all we had to do was take a derivative and kind of look and see what's happening. They are going to get more interesting. Okay, problem 4 is not really a Newton's method problem at all, but we'll use this result for a future problem to set it up correctly. So if you have, if you have your function is equal to x minus a squared, or if you have f of x equals x plus a squared, these are both parabolas, and this one is shifted a units right, and this one is a parabola shifted a units left. Now, because there's no minus sign in front of these parabolas will both, so let's see. So this one would be a units to the right, so a is over here, and it's going to point up like this. This one, a would be somewhere over here, and it's going to point up like this. If there's a minus in front of the parentheses, then it would make the parabola point down. So the only one that makes sense is if we have x minus 3, this is 3 to the right. It's been shifted. So our parabola looks something like this. 3 units to the right. Okay, so also pretty straightforward for problem 4, but we're going to use that a little bit later on. Okay, problem 5, this is where we're going to have to start doing Newton's method ourselves. So here we go. So it says our function should be, they want us to find the 4th root of 78. So what we're going to do is say that's x to the 4th minus 78 equals 0. So again, if I were to solve this, I would get x4 equals 78, or x equals the 4th root of 78. So you almost have to undo the 4th root of 78 to get the equation. Then the derivative of this is going to equal 4x to the 3rd. So the minus 78 will go to 0. Now Newton's method says x of n plus 1 equals x of n minus the original equation, x4 minus 78, divided by its derivative, 4x to the 3rd. And now I'm going to take my first guess to be, let me match up my notes, I guessed 3. Because I looked at it and I said, okay, 2 to the 4th is 16, that's too small. 3 to the 4th is 81, that's pretty close to 78, so that's going to give me close to 0 on top. And then if you pick x is 4, it's a little bit too big. Now, the beauty about Newton's method is you don't have to have a perfect guess. It will oftentimes still converge on the correct answer, even if you're way off on your guess. Now, there's times when it doesn't do that, and we'll see a problem like that. But oftentimes, it's a pretty good method that can hold up against kind of different values of your first guess. So we get x2 is going to equal x1. Actually, let me put this in here. This would be x1 minus x1 to the 4th minus 78 over 4 times x1 to the 3rd. Well, we know x1, it's 3 minus 3 to the 4th minus 78 all over 4 times 3 to the 3rd. And if you do this, again, I'm going to kind of trust that you can type these in your calculator, and that's no easy task. You're going to have to use parentheses and order of operations and power button key and all that stuff. But if you do that, I got x2 to equal 2.97222. Okay, now that's your next guess. So you're going to say x3 is equal to this number now, 2.97222 minus 2.97222 to the fourth power minus 78 all over 4 times 2.97222 raised to the third. And if you do that very carefully with your calculator with all those buttons, you should get x4 is 2.9712828. Okay, and then you're going to say, oops, not x4, that's still x3. Still x3. Then x4, I'm only going to write one more of these, is that number, 2.9712828. Let me make sure that's right. 971282897. Okay, that's right. Minus 2.9712828 to the fourth minus 78 all over 4 times 2.9712828 raised to the third. And if you do that, this becomes, this is x4, it is, oh, I actually missed a step, shoot. This should have been, that should have been x4. Let's see, x3 should have been 830. Dang it, looked at the wrong one. This should have been 30, which means this is 30, which means this is 30, which means this is 30, and then you get the 2.9712828, and that's x4. So I actually missed a number. I missed this, one of my intermediate values in there. And you keep going on this until you get, I think on x5, let me see. No, I had to go all the way to x7 to get this. So to 8 decimal places, I had to go all the way to x7 equals 2.9718287. Okay, so don't really want to do these by hand. That's a lot of work, but you do get really, really accurate answers. So let's go and see problem 6, where I will teach you how to do this with Microsoft Excel. Okay, so we have, now this problem's kind of complicated, because they say use Newton's method to find the absolute maximum value of the function fx equals 2x sine x. Well, the absolute maximum value of a function is when its derivative equals 0. So our function is equal to 2x sine x. Our derivative is what we're trying to make equal to 0 would be, you have to be real careful here. You have to use product rule. So this is f, this is g, so we're looking for f prime g plus g prime f. These are being multiplied. So we get f prime is 2 times g, which is sine x, plus g prime is cosine x, times f, which is 2x. So we're looking for when 2 sine x plus 2x cosine x equals 0. So the tricky part about this problem is that is your function. So this is the function we're actually trying to minimize, so, or not minimize, set equal to 0. So we're going to say, let's reset this problem now and call that f of x. So now I need the derivative of that. So the new f prime would be the derivative of this, which would be 2 cosine x. Same idea, product rule. Derivative of the first thing would be 2, leave the second thing alone. Plus leave the first thing alone times the derivative of the second thing, which would be minus sine x. So we get the derivative is equal to 2 cosine plus 2 cosine is 4 cosine, and it's going to be minus 2x sine x. Okay, now Newton's method will say the second guess or subsequent guesses is equal to our first guess n minus the function, but remember we reset this problem. That's the function, this is the derivative, So we're going to be real careful how we set this up. We're going to have the original function on top, which is 2 sine x plus 2x cosine x. And we're dividing that by the derivative, which is 4 cosine x minus 2x sine x. Okay, so this is what we're going to try to type in Microsoft Excel, and we'll show you how to kind of run through the different numbers that you're going to get. Okay, so let me clear this out and go to Microsoft Excel. And I already did this, but I'm going to completely do it over again. So this is our first guess. Let me just put it as 0 for now. Clear everything out. Okay, so I'm going to completely start over. This is my function. I type the equal key, and I'm going to type now I break this into parts. So I type this column is just the original function, this column is just the derivative, and then this column is going to be our second guess. So we're going to put equal to 2 times, which is shift 8, and then type sine, parentheses, and I need x, so I'm going to click here. That's x, xn. Then I'm going to close the parentheses, and then I'm going to say plus 2 times this function, and it's going to be times cosine of, click that button again. So actually, let me write on the screen again what the function was so you can see how I'm getting this. So we are saying xn plus 1 equals xn minus, the function was 2 sine x plus 2x cos x all divided by 4 cos x minus 2x sine x. And we just typed the numerator. So that right there is the numerator, the 2 times the sine plus 2x times cosine x, and x is really a reference to the cell A4, which is going to be our first guess. So I hit enter. Now for the second, this block is going to be the derivative, the denominator. So I hit equals, and I type 4, shift 8, which is times, type cos for cosine, parentheses, click on this xn, our first guess block, which is A4, parentheses, to close that out, minus 2, shift 8 for times, click that again to get A4, times sine, sin, parentheses, click that again to get A4, the x value, hit parentheses, hit enter. Okay, now I'm going to type this is equal to, this is my second guess, so this is equal to my first guess minus f of x divided by f prime of x. So I'm clicking and I'm hitting divide by to get what will be my next guess. Now I say this has to equal that. So my next xn is equal to this xn plus 1. And then I'm going to copy. So I'm going to select those, hit Control C to copy, click here and hit Control V to paste. And now I can grab all 4 of these and hit Control C to copy, and then drag down and hit Control V to paste. And now I can start guessing. So I click in here and I say guess 1. And it's going negative. Did they tell us what our, did we have a restriction on our x here? Oh, so x has to be between 0 and pi. So if it's going negative, that could be an answer, but we can't use that. So let's try 2. Okay, that looked nicer. So notice how it's going down, and these numbers are becoming exactly the same, and so that is going to be the answer. So our x value is 2. Now in this problem, they don't want the x value, they want the actual maximum of the function. So the last step is to plug 2 into this original function to get the actual maximum value. So what you would do is then say, you would now find what is your function when x equals this number, 2.028758. Well, that equals, the function was 2 times x, which is 2.028758, times the sign of this value, 2.028758. And if it were me, I would make sure I was in radian mode and find that number, then multiply it by this x, and then multiply that by 2. And if you do that correctly, you should get, for my numbers, I get the maximum y value is 3.639411. And you got to be really careful. So if they want 6 decimals, you kind of have to go to, well, I guess I only went to 6 for my x value, so it should work out, but you definitely want to go all the way to 6. You can't shortcut this and only get 5 decimals right. It will cascade that rounding error all the way to get the problem wrong. Okay, so that's problem 6. Problem 7. Use Newton's method to find the coordinates correct to 6 decimal places of the point on the parabola y equals x minus 7 squared that is closest to the origin. So for this problem, let's go straight to Excel and look at it. So we're going to have let's write our function. Our function is x minus 7 squared. So this is a parabola, and actually, I'll leave it like that. They called this y. So we have a parabola shifted 7 units to the right, and it's going to point up. And they wanted us to find the distance from the origin, which is 0, 0, the closest point to this parabola. So what's the closest point from that parabola to the origin? And noticing that that point on the parabola is x comma y. So we have to use distance formula. So this is the distance from the origin to this point. Well, distance formula says that between 2 points, it's their x value subtracted, so x minus 0 because the x, so this is x and y, and then plus y minus, in this case, the origin squared. So it's Pythagorean theorem. Now that's fine, but we don't want to use that because if we have the square root of this in there, the derivative is going to be ugly. So what we're going to actually solve is d squared, which is just, in this case, x squared plus y. But what is y? Y is actually this right here. So it's x minus 7 squared but then we're also squaring it. So d squared is equal to x squared plus x minus 7 to the fourth. Squared squared becomes fourth. So we're actually trying to minimize that. So to minimize that, we take a derivative of this equation squared, and we get 2x plus 4x minus 7 to the third. And actually, this is just like the last problem. We're trying to minimize this derivative. So to minimize the derivative, we need a second derivative. So it's 2 plus 12 x minus 7 squared. And then Newton's method says n plus 1 equals xn minus the original function. So this is now really f of x, and this is f prime of x. So we're going to have 2x plus 4x minus 7 cubed all over 2 plus 12x minus 7 squared. So that's what we're going to try to type in. I'm going to start over and type it in again. So I'm going to say f of x is equal to 2 times, click on the xn block, then it's plus 4 times, parentheses, click on the xn block, minus 7, close the parentheses, shift 6 for the power key to the third power, enter. So that should be the numerator when x is, I guess, 5 in this one. Then I hit delete, well, for mine, because it's already filled in, but for you, it'd probably be fresh, equal sign. Now we're typing the denominator, 2 plus 12, shift 8 for times, parentheses, shift 9, click on xn, minus 7, shift 0 for parentheses, shift 6 for power button, 2, enter, and then we're going to say the next x is equal to xn minus, and I'm hitting the over arrow now to select the box, fx divided by over to f prime of x, enter, and now I can just select, I can say this cell has to equal that cell, and then click and drag, right click, copy, click and drag, right click, paste, and then click left and drag, right click, copy, click and drag, right click and paste, and if this works, we should be able to get the right x value. So I can try 1, still converges to 5.591273, 2, 3, they all converge to the same number, 4, 5, 6, 7, 8, still converging, 9. So even really bad guesses like 9 will still get us there, but look at 9 is a little too far away, so that answer right there is not going to be close enough. So you can kind of play with this until you get the right number that's close enough. Now, just like the previous problem, that's your x value. So they want both. They want you to report the x and the y value for this. So you would type, okay, my x value is 5.591273, but my y value, I have to plug this x into this. So it's going to be 5.591273 minus 7 and then square, and then you'll get this answer, which let's just look at what I have for my answer. It was 1.984512. So you do have to plug that x value into your y equation to get the final answer there. Okay, that one's probably the only, well, okay, 8. This one's really pretty simple. We have, let me do it in Excel though. Let me jump right over there. Okay, so we have problem 8. This one's straightforward. It says the function is equal to for my numbers, 3x to the fourth minus 8x third plus 5. The derivative is very straightforward. It's 12x3 minus 24x2. And they don't want us to do anything other than just solve this. They don't want us to find a second derivative or anything like that. They are trying to find when this is 0. So we're going to say xn plus 1 equals xn minus 3x4 minus 8x3 plus 5. And then when the denominator, 12x3 minus 24x squared. Okay, so we got to type this in Excel. So we're going to say, let me start over. This equals the numerator 3 times, click here, shift 6 for caret, 4 minus 8, shift 8 times, click here, shift 6, caret, 3 plus 5, enter. That's the numerator. The denominator would equal 12, shift 8, click here, shift 6, 3, minus 24, shift 8, click here, shift 6, 2, enter. This is equal to this guess minus this f of x divided by this derivative, enter, and then we're going to say this is equal to this answer, and then we're going to say copy these two. There's more than one way to do this. This is just what I came up with earlier today, so if I thought about it, I could probably streamline this more, but this works. Select all those, copy, and select all those, and paste. And now we have, in this one it said the answer should be between 2 and 3. So there's really no, I can guess 2, and I can't get it because 2 gives me divide by 0. So that's kind of a good one to try. Let's see what happens with 3. Okay, 3 would have worked. But if they say guess between 2 and 3, might as well pick 2.5. And we find the answer is 2.568284. There is one more part to this problem, and that is they want you to actually prove that there will be a 0 in between 2 and 3. So if you plug 2 into the original equation, for my numbers you get negative 11. If you plug 3 into the original equation, with my numbers you get 32. So this is intermediate value theorem that we studied a while back. So I've got some function here, and at 2 and 3, at 2 I get negative 11, and at 3 I get 32. So I have the point 2, negative 11, and 3, 32. The only way to get from the blue dot to the green dot, no matter how I draw it, I have to go through the x-axis. And that point right there, when we introduced this, we called C, and f of C equals 0. And we just proved C was the value 2.568284. So we use Newton's method to prove, and they want you to say f of C should equal 0. Well, we used intermediate value theorem to prove there's a 0 in between those two numbers, and then we found it using Newton's method pretty quickly too, if you think about it. I never had to reach for a graphing calculator. I didn't have to solve a fourth power polynomial, which would not be that easy, and we can pretty quickly do this. Okay, for problem 8. Okay, problem 9. This one's a doozy. So let's go to Excel and we'll see what we've got here. So the function is x over x squared plus 1. Actually, let me first introduce it the way they introduce it. They give you an equation that says this: x over x squared plus 1 equals square root of 1 minus x. And like I said before, the only way you can use Newton's method is if the function equals 0. So it's called a root finding algorithm. So it's finding roots of the equation. So if we have x over x squared plus 1, we have to subtract 1 minus x to get this to be 0. Now that is the function. Okay, now the hard part of this is the derivative. So we're going to have the derivative of this. Now for this first one, we have to use, just for this one, we have to call that f and this g, and we have to use quotient rule, which says that the derivative is fig minus gif over g squared. So this first derivative is going to be f prime, derivative of x, which is 1, times g, which is x squared plus 1, minus g prime, which would be 2x, times f, which would be x, all divided by g, which is x squared plus 1 squared. Okay, that's just the first part, the green bubble. That's its derivative. Then we have minus. We're going to write this as 1 minus x to the 1/2 power. So the derivative of that would be bring the 1/2 down, write this exactly as it is, subtract 1 from 1/2, which would be minus 1/2. Then it's times the derivative of the inside, which would be negative 1. So the derivative of negative x is negative 1. So we get f prime of x equals, distribute this 1 and combine these x's, we'll get x squared plus 1 minus 2x squared all over x squared plus 1 to the second, and then this is going to be plus, because of the double negative, 1 over 2 times the square root of 1 minus x. Then the last thing to do is write this as, you've got x squared minus 2x squared, so it's 1 minus 1x squared over x squared plus 1 squared plus 1 over 2 square root 1 minus x. Okay, now watch carefully how I type this in. This is hard. This is the hard part. So I'm going to clear this out. Equals, I'm just doing the original function. So I'm going to do x, which is this, divided by parentheses, that again, raised to the second, plus 1 in the parentheses. Then it's minus, and for square root you type SQRT parentheses, and we're going to have 1 minus xn, click that box, end parentheses. Enter. That would be the numerator. The denominator, this one's a real doozy. It's parentheses 1 minus, click the x box, raise that to the second, parentheses, divided by a new parentheses, click the x box, raise to the second, plus 1, end the parentheses, raise it to the second. Okay, then it's plus 1 divided by, I would use parentheses for the whole thing, 2 times the square root of 1 minus, click the x box, end the parentheses for the square root, end the parentheses for the denominator parentheses, then you can hit enter. And actually, let me click in that again because you're probably going to want to see that, and let me delete because the F got in the way of it. I could see that. So let me kind of cut him up a bit. F prime. Okay, let me see if you can see that again. So click in here, and I guess it's not going to show it anyway. Well, this is it, if you can kind of look at that. So we've got a parentheses for the numerator, then a division, then a parentheses for the denominator, then a plus, then a 1 divided by parentheses for the entire denominator. Okay, and then we're going to say, oops, what did I just do? This is equal to xn minus f of x divided by f prime of x, enter. This is equal to this one up here. I just got to copy these two one time, copy below it, paste. Then I can grab all four, right click, copy, click and drag, right click, paste, and we have our answer. And this one's really, if I remember right, this one's really kind of nasty. If you pick this number wrong, it will not work. So I just went from 0 to 1 and it completely went off the rails. 2 doesn't work, 3 doesn't work. So anything above 1 doesn't work. 0.9, okay, that worked. Let's try like 0.1. Okay, that worked too. And here's why. If you look at this original function, it's kind of weird. It looks like this. So over here, here's 1. Now if you think about it, you can't have any number bigger than 1 because you're going to get a square root of a negative value. You're going to get an imaginary number. So if you were to plot this like on Desmos.com, it goes like this up through here and then it stops right there at 1. So it just stops in midair. And the number we're looking for is just shy of 1. It's right there. And we discovered it was that 0.7668259. So that is what we'll type into WebAssign. So we go over here and we type that in, 0.7668259, and we get it just fine. Okay, that's problem 9. Now problem 10 is one of these where I don't usually assign these, but there wasn't a lot to pick from in this section that weren't really, really long problems. So what they want you to do is look at sine x minus 0.6x squared. So we can find this pretty quickly. The function is sine x minus 0.06 x squared. Therefore, the derivative is cosine x minus 0.12 x. And Newton's method says your next guess is equal to your first guess minus sine x minus 0.06 x squared all over cosine x minus 0.12 x. And they've already coded that up, and they're going to let you pick your first guess. So what they want you to do here is use this a as your guess. So if I go, they want you to pick 1 to start. So if I go near 1, it's really hard to get it right on line. Oh, I did. That's the first time I got that. Okay, and I hit step, so it gives me 1. My next guess should be 0.78. So I hit step, and then it becomes negative 0.859. Step again, 0.201. Step again, negative point something. Step again, negative. So it's getting really close to 0, and then it becomes 0 on the 6th guess. And it turns out that 0 is the actual value that will make this function 0. So it took us 6 steps to get to the origin as the answer. Then it says, what happens if you pick x1 equals 1.1? So we move this over to 1.1, and we go step, 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 and you keep hitting step, and this value never goes to 0. So you're looking for oh, that's weird. It shouldn't have actually found that. It does find 0, but oh, I see. So it gets another 0. This time it gets 2.681826. So it found a completely different root. So 0, 0 is a root, and then 2.691826 is a second root. And that number was just slightly different from our starting value. That is one drawback to Newton's method, is that if there's a lot of zeros close together, it can drastically jump from one to the other one depending on what your guess is. Okay, and then you don't have to type anything in here. This is a problem where I'm not going to grade all these answers for all students. It's too many. And so I'll just end up giving the entire class credit for these boxes. The only other one you need to answer is this last one, which says, what happens if our initial guess makes the derivative 0? That's the key, the derivative 0. Well, if you guess a number that makes the derivative 0, then you get to divide by 0, so you obviously can't use Newton's method. So Newton's method will fail because you get a division by 0. Okay, so that is everything we want to kind of test you on or show you for Newton's method in Chapter 4, Section 8.